We're going to continue learning about solving equations, and now we're going to extend that into multiple angles. So you can see what I've highlighted here. I've highlighted the angle. It's no longer just a 1x or a 1 theta or a 1t. Now it's a 3t. So that's a multiple. When you have that coefficient in front of that variable and that happens to be the angle, it's called a multiple angle. So our steps are still the same. We want to definitely consider the period. So I'm just going to recall that. Consider the period. Then we want to isolate the term, and then we are going to solve for all solutions. Solve for all solutions. So let's get started. We're going to add 1 and then divide by 2. So I'm going to be left with cosine of 3t equals 1 over 2. And then we say, well, what angle do we put in for cosine to get 1/2? So cosine is the first value of the ordered pair. So we're talking about a pi over 3 angle, but not just pi over 3, because the period in this case is 2 pi. So when we're talking about a period of 2 pi, we're talking about all 4 quadrants. We've got a positive 1/2 in quadrant 1, and also we'll have a positive 1/2 in quadrant 4, because the x value is positive, right? So that tells us that our angle, I'm just going to write that here, our angle is equal to pi over 3 plus 2n pi, and our angle is also equal to 5 pi over 3 plus 2n pi. So that's easy enough to understand, right? However, what is our angle? Well, our angle is 3t. So 3t equals pi over 3 plus 2n pi. 3t equals 5 pi over 3 plus 2n pi. Well, when we have that, I'm going to rewrite it here. 3t equals pi over 3 plus 2n pi. I don't want to solve for 3t. I want to solve for 1t. So just like any other equation that you solve for, you're going to multiply by 1/3, multiply by 1/3, multiply by 1/3. The reason we're multiplying by 1/3 is because 1/3 times 3 is 1. So that's going to leave us t equals pi over 9 plus 2n pi over 3. That's one of our answers. The other answer, 3t equals 5 pi over 3 plus 2n pi. We're going to multiply again each term by 1/3 so that we can solve for 1t. So the 3's cancel. We get t equals 5 pi over 9 plus 2n pi over 3. And there's our solutions. Okay, let's try that again. We have solve for 3 times the tangent of x over 2 plus 3 equals 0. So I'm going to first consider the period. The period for tangent is pi. So we're talking about just quadrants 1 and 2. Get my black pencil. We're going to subtract 3 and divide by 3. So we'll have tangent of x over 2 is equal to negative 3 over 3, which is negative 1. I'll just write negative 1. And where is the angle that gives us a ratio of negative 1 for tangent? Well, tangent is going to have a ratio of 1 whenever x and y are the same value. And it's going to be negative in quadrant 2. So x and y are the same value at 3 pi over 4 with opposite signs, making it a -1. X over 2 equals 3 pi over 4 plus n pi. So we only have one equation, and that's because the period for tangent is pi. Now I'm going to multiply each term by 2 so that I can solve for 1x. So that's going to give me x equals 2 goes into itself once, 2 goes into 4 twice, 3 pi over 2 plus 2n pi. So there's our infinite number of solutions. So that's how you solve for a multiple angle. Now in the next video, we're going to increase the intensity a little bit by adding that quadratic. And then you see that we start adding in the interval. So in the next video, we'll expand and go to the next level on solving these trig equations.